Let's do a derivative application. Here we have a particle. It's moving along a line, and the position of the particle on this line is given by our function s of t as shown. S being measured in meters, t being measured in seconds. Our first question is, what is the velocity of this particle? The velocity is a measurement of the change in position over change in time. And since we are being asked to calculate that change at an exact moment, that means we're being asked to find the derivative of position with respect to time. So calculating s prime of t, or the derivative of position, which we now can refer to as velocity, we can apply the simple power rule to calculate that derivative. It's negative 3t squared plus 14t minus 14. If we want to know the velocity when t is equal to 3, we're just calculating s prime of 3, or velocity at time equals 3, which gives us negative 9, 3 squared plus 14 times 3 minus 14. Calculating that fairly quickly is negative 27 plus 28, or 1 meter per second, given the units we were told in the problem. The second question we're asked is, at what time t will the particle be at rest? Well, at rest means no velocity, or it's not moving at all, so velocity is equal to 0. We've already calculated a velocity equation by doing the derivative of position. Now we just need to set that equal to 0 and figure out what value of t solves this equation. We have a quadratic equation. It's not factorable, so I would just plug it into the quadratic formula, and when you do, you get two different values for t. I'm approximating here. T will be about 1.45 or about 3.22. So we see the particle is at rest at two different moments. Our last question is, what is the acceleration when that particle is at rest? Now, acceleration is a measurement of the rate that velocity is changing as time is changing. But yet again, since we want to know it at a precise moment, we need the derivative of velocity with respect to time, the instantaneous rate of change. We have a function for velocity. We just need to take its derivative, or we could refer to that as acceleration if we would like. Again, the power rule will solve this derivative for us, negative 6t plus 14. To calculate what those accelerations would be, we need to plug in our two different times. So acceleration at 1.45 and acceleration at 3.22. At time equals 1.45, acceleration is approximately 5.3, and that is meters per second squared. And at time equals 3.22, it's approximately negative 5.32 meters per second squared.